The flame becomes more and more apparent.
Why we call it cold plasma, and why do we use argon into the skin so you can actually perform certain treatment?
Describe, first of all, this is our prototype. It's really strong. Really strong flame.
Cold plasma, normally the temperature is much less. You've got In this video, we're going to talk about cold plasma and hot plasma. We're going to talk about the difference between the two of them, and then we're going to show you at the end of this video a practical example of cold plasma. But first of all, we have to actually talk about a few points that are quite basic in terms in order to explain what cold plasma is, what we refer by cold plasma, why we refer to cold plasma, and the physics of it. So if you understand the basics of the physics of it, then when we show you the example, then you'll understand more what we are doing. So it's very important that you understand this first part of this video. So I may be repeating the same concepts over and over again to make it as clear as possible. Now let's get into it. Now, why we call it cold plasma and why do we use argon? Because the main difference between hot plasma, which is plasma or voltaic arcing in air or in nitrogen, and arcing where we use argon, is that the energy of the arc is distributed differently. And namely, what happens is at the surface of contact of cold plasma, normally the temperature is much less. You've got a higher degree of control over the energy that you inject onto the skin, and we're going to see that shortly and how and why. Whereas in hot plasma, whenever you have an arc, the energy is much higher than what you've got with cold plasma. So why cold plasma? The main reason for us to call it cold plasma is because the temperature at the surface of contact between the ionized gas and the skin is relatively less than what you've got in arcing in nitrogen or arcing in normal air, in atmospheric air, the air that we breathe day in and day out. And this is the same as hot plasma. What we refer to as hot plasma is the arcing that you see in all other devices on the market. Whereas cold plasma is what we refer to as the plasma or the ionization of the gases when we use argon. So very important. So what is it? Again, I'll repeat it again. The difference between hot plasma is what we've got is that electric arcing, that electric discharge when the tip of the device and the skin are insulated only by atmospheric air, only air. Whereas cold plasma is the same ionization of the gas, in this case argon, when between the tip of the device and the skin we've got argon. Now, hopefully that distinction is very clear. So what we refer to as hot plasma is the normal arcing plasma that you've seen anywhere else, Plex or whatever devices you want to have, what you call a jet plasma, whatever. And cold plasma is that same physical phenomenon that you see in atmospheric air but using argon. So why do we choose argon? The main reason is, number one, is very safe. So you can put it in any environment and it's non-poisonous. It does not ignite because it's very inert, so it does not ignite. If you've got flames, naked flames or sparks around, it does not ignite. That is very important. So it's extremely safe and it does not cause any danger to people or things in the environment that you're putting it into. Very, very important. So you can saturate, almost saturate the whole room with argon, and it does not kill anyone. Very, very important. So you can have a full place full of argon and doesn't actually change much. Whereas there are other gases which are more dangerous. And the most important property of the argon is that its dielectric strength is much lower than air. So the dielectric strength in physics is a parameter that indicates how a material, a piece of solid or fluid or liquid, whatever, works as an insulator versus a conductor. So, for example, air has got a relatively high dielectric strength, because if you put something in air, normally air works as an insulator, so there's no conduction between two electrodes normally in normal conditions, but things can vary if the voltage is too high or frequency is too high. Things can change, but normally if you put things in air, there's no spark between them normally in most conditions. Whereas if you change the medium and you put two electrodes, say for example between argon, then you have ionization of the gas, and you've got light, you've got other phenomena. So this is the main thing. So the lower the dielectric strength, the much easier is for that material to become ionized and to behave as a conductor. The higher the dielectric strength, the more difficult for that medium is to behave as a conductor. Very, very important that. So air has got a higher dielectric strength than argon. And there's many other gases that have a lower dielectric strength than air. But most gases have certain properties that can be dangerous, they can be poisonous, they can be flammable, they can be expensive. Whereas argon, again, is very safe, it's not poisonous, it's odorless and everything else. It's got a very low dielectric strength, though, so that you can create the arc much more easily than in air. And you've got a gas that is very easily available within the market, so it's very, very inexpensive. So this is the main reason for you to get argon when you're trying to create cold plasma. You can actually create cold plasma using other gases, but other gases are not as good as argon for this application. This is why historically argon has been used for these applications. Now, what are the implications of using cold plasma or ionization of the gases using argon? So in aesthetics, what are these implications? And then we're going to go back to them later on. You can actually perform all the same ablative aesthetic treatments as before in hot plasma, the plasma as you know it. It's much more easy to use, so you can use the device much more easily. There's less pain involved if you want it to be less painful, and you can perform certain treatments which are not possible using hot plasma because of the physics of hot plasma. And we're going to actually explain this right now, and then you're going to see the examples. Anyway, let's go again to the difference between hot plasma, when we've got the electrode in air and we've got the electrical arcing in the skin, and the cold plasma where we've got the electrode, the argon that flows through a tube and flows into the skin, and then you've got an electrical arc in there. Okay, let's go into that. So what is the difference? Mainly the similarity is that in both cases we've got a electrode. In the case of hot plasma, the electrode is completely naked. There's nothing, there's only air between the environment and the skin. And in cold plasma, we've got argon. We're trying to get argon in through the tip of the device into the skin. What you see in the oscilloscope at the tip of the device is the same. So it's to say you see a sine wave. But what happens is, when you've got the traditional voltaic arcing, the energy is very, very focused and is very high. Why? It's very high compared to cold plasma. Why? Because the electric strength is relatively high, and you have a medium which is air, which normally wants to behave as an insulator. And in order for air to work as a conductor, an electricity conductor, you have to apply a lot of energy. And therefore, when you have an electrical arcing between the tip of your device and the skin, normally that ablation is quite deep. And you've got very focused ablation. If you've seen all of our videos, you've seen a very, very focused ablation. Whereas the same thing, it's not the same as arcing using argon, because the ablation can be less focused and more spread out. And also the energy can be much, much less. So you've got an ablation which is much, much, much milder and much, much thinner. Whereas here is much, compared to cold plasma, is much, much deeper. You've got a deeper ablation with hot plasma, less stable arc. So as you've seen, as maybe you've tried it already, sometimes it's quite difficult with a low energy arc to cause that arc to ignite. We've got a much higher localized temperatures at the surface of contact between the arc and the skin, obviously because you need a much higher energy in order to cause that the arc. We've got more painful treatments that requires some anesthetics. Then you require more energy normally to sustain the arc, and the arc is not as easy to sustain. So the higher the energy of the arc, the easier it is, but then it's going to be quite awkward to perform the aesthetic treatments. Whereas the game changes completely when you use cold plasma or plasma in argon, because although you've got the same sine wave there, the energy is spread over a wider area, if you want it to be, of course. The energy is less focused, and you've got a less focused ablation, so the ablation is spread over a wider area and is shallower. So you've got shallower ablation and much less energy applied onto the skin. So you can actually perform certain treatments that are not possible using hot plasma because you've got less energy. So we're going to show you in the next part of the video what we mean by that. Then you've got lower localized temperature, if you want it to be lower localized temperature, because you can have also very high localized temperatures but change in a few parameters. Then you've got, if you wanted to have less painful treatments, you can get less painful treatments. It requires much less energy to sustain the arc, and that's going to become apparent shortly. And you've got something that is not possible with arc using normal air or hot plasma. As you say, when here you've got the tube, yes, here this is the tube, you've got the gas that goes through the tube, through the electrode, and then goes onto the skin. Basically that arc can take place at distances that are not possible using hot plasma or the plasma in air, because the electric strength is far higher. So say for example, if at this distance, using the same sine wave at the same frequency and the same voltage, here you've got an electrical arcing which you actually feel and see. Here at that same, if you're using only air at the same distance, you don't have anything. It's very, very important that. So, and we'll see it in a practical example. And then when you shorten the distance using hot plasma, then the energy that you apply there is much, much higher. So you can actually change the amount of energy that you apply onto the skin by reducing the distance. Another parameter not possible with using hot plasma, because it does not matter when you use plasma in air the distance between the tip of the device and the skin. If there is an arc, the arc pretty much delivers the same amount of energy. Doesn't matter how close you are to the skin, pretty much the energy is the same. Whereas here you can modulate the energy using modulating that distance as well, whereas you cannot do that. So basically, in hot plasma, you either have the arc and it delivers that energy, or you don't have the arc and you have no energy delivered. So a basic point. But let's go again and recap. The similarities is that here in hot plasma, you've got sine wave, and in cold plasma, you still have the same electrode and the sine wave. In the hot plasma, you've got a naked electrode with nothing around it, or something else, but there's nothing really fancy about it. In this type of arcing, in cold plasma, you've got a tube where argon flows through the tip of the device onto the skin, and you're able to cause the ionization of the arc of the gas of argon much more easily. With cold plasma, you've got quite a relatively easily generated arc. With hot plasma, the arc is not as easily generated. So that's very important. Now let's go back and look again into the implications of this new thing, which is cold plasma. So with cold plasma, you're able to perform all the same aesthetic treatments as before, and that is going to be apparent in a minute. You can actually do the treatments with much more ease, because the arc is much more easily generated using argon than it is using air. It can be, if you want it to be less painful, and you're able, due to the physics of cold plasma, to perform treatments not possible using hot plasma, like skin resurfacing, where you actually apply the arc onto the skin in a swiping mode, and you're able to wipe off the outer layer of the skin very easily using this method. But I think this is all for this part of the video. Now the most important part of the video is the following, when you'll see a practical example of cold plasma, where things are going to become even clearer.
So in this part of this video, we're going to show you the cold plasma. I'm going to describe, first of all, this is our prototype, and the circuit has been done already. It's still on trial, we're still changing a number of things, but this is how we have configured it for this test. So we have the power transformer here, and we've got the gas that flows through this tube and is focused there, and here at the tip we've got a what do you call it? Yes, we've got the I still hear a bit of pressure here. We've got the tip of the device here. We'll see where I can actually show you. Look here. So here we've got the tip of the device, and gas flows through here. The tip of the device there, and we've got the other tube in here to focus the gas. It's not optimal configuration, but is something that we can use in order to show you the cold plasma and how it works. And all we're going to do is just increase the pressure here, so the argon flows through this tube and onto the skin. So we're going to show you this right now. So first of all, what we're going to do is just going to go and have the device operational, which is actually operational at the moment. I'm just going to press quit just to show you what mode we're using, which is the manual mode, where the arc is on all the time. And all I have to do here is just get this close to my hand. So I'm just gonna go and give you the maximum zoom. See where we are gonna actually do it. See, I can do it here. Really, yeah. See, show you in a better position. Okay, let's have a look. Get a better position is there. Yeah, hopefully should be able to see it here somehow. It's loads of light. Today is a very sunny day. So let's get started. So what I'm gonna do is just start to open the valve to the gas, the argon gas. And got my hand here as usual. That's my test. And here, if you can see the blue, you see the blue is that ionized gas into my calyces, and it's like looks like almost a laser, but it's not. You can see the blue there. See whether I can actually show you in a better position. So here we got it again. So as you see, there is the blue flame there, which is the arc. As I get close, the arc gets stronger and stronger. And I get, so the closer I get, the stronger it becomes. And if I get a bit further away, there's still the flame, but it's not as painful. I can still feel it, but it's not as painful. So if I get closer, oh god, yes, it becomes really strong, really strong flame. So the way it works is quite different to what we've got in the hot plasma, as you can see. So again, right here, if you actually, hopefully you can see it from this camera. I mean, the flame is already on. There's if you look at the tip of the device, you're just gonna get closer and closer. Now the flame becomes more and more apparent, and as closer I get, the stronger it becomes. But here, there's actually ionization of the gas. Look, you can actually see it there. Gas is getting ionized. But I cannot feel as much, but if I get closer, yes, it does. You can see there is ionization of the gas, but it becomes really effective when I get close to the skin. And also, the other thing is that this gas pulls down the skin, so also that pain associated is less because you've got the instant cooling of the skin. So very important that you can see this in action. It's a very simplistic model, but it gives you an idea of what hot plasma can do. So basically, when you're doing a skin resurfacing, all you do is just go and spray this plasma on the face of your client, and it gets rid of the epidermal layer. Very good treatment. Things that you cannot do with the hot plasma. And then if I switch it off, for instance, I just switch off the gas. Basically nothing happens. There's no arcing. But if I actually get it closer, I will manage to get some arc. In fact, I did actually get one. Do again? Yes, I did get one because I get close enough. So you've got an idea of how this works.